power saving mode. Now we're recording.
Okay,
so to recap, one time through. First, you have to get rid of the exponents, the coefficients, excuse me, by making them exponents. Then, from here, you can combine them. In this case, was there anything simpler you could do first? Anyone notice anything about, I don't know, this term?
That's what I did first. I just made it 1.
You just made it 1, right. Log base, very good, Rodney. Log base 10 of 10 is 1. So this expression, if I go up here, I can just make it 10 log x plus 2 times 1. What 10 to what power equals 10? 1. So this is 1, get rid of it there. And then this just equals, I can still bring up the exponent, make it log x to the 10th power plus 2, and that's a fine way to leave it also. I'm actually not sure which one the book more wanted. Rodney, I like this way better, because it shows you know what logarithms mean. The directions did say to condense, and this one you can't condense further because this isn't a logarithm. Questions on either one of these methods? I like this one better. I'd give full credit to either if the directions were condensed.
How did you... Oh, no, I think...
Okay, remember, every logarithm is a question. I can't say that enough. Every single logarithm is a question. And the answer is an exponent. This is asking you, 10 to what power equals 10? Answer's 1. If you know the answer, you should be able to do it. Yes?
I have 2 questions.
Okay.
The first one is 26 and then 58. I don't know.
Let's do 58 next, because that should be on a roll with this one. Let's keep condensing. What does 58 say?
Log base 5 to the 7.
Log base 5 of?
7.
7, okay.
No, why did you write it like that?
Because you said log base 5 of 7.
That's the problem.
This is the whole problem? What are the directions? This is no longer condensing, is it? Change the base formula. Okay. Log base 5 of 7. You have a couple of choices here. Thank you, Rodney. I was very confused by what to do next. I can change this to the natural log of 7 over the natural log of 5. Or I can change this to the log base 10 of 7 over the log base 10 of 5. I can change it to any base I want to, actually. But these are the two my calculator will help me with. And they will give me some decimal approximation that I don't remotely know off the top of my head.
1.2.
Pardon?
1.2.
1.2. That seems about right to me. For reasons I may have time to go do later. So that was a calculator question. That's not one I can give you any trick to answer other than the change of base rule itself, which we may sort of prove today accidentally. And Amanda, you said number 26.
Yeah.
What is the problem, and do you know what the directions were?
I don't know what the directions were, but I know the problem.
Okay, what was the problem?
Log, and then parentheses 1/5.
Okay, this is one where they told you the value of log base 5 and log base 15, right?
I have 4.
Okay, you gotta have the book with you. Rodney, what did they say that the log base 10 of 5 was about? 0.6 something? 0.699. Okay, seriously, pay attention to this one. It's on a ton of standardized tests. Okay? They'll tell you something like the log base 10 of 5 is 0.699, and then they'll say use that without a calculator to figure this out. Okay? So here's what I'm going to do.
Can you round that?
That is rounded. If they give it to you out to the 1,000th place, then they want you to keep it out to the 1,000th place. This isn't one I pulled off the calculator. This is one the book gave you this way. Okay, is log base 10 of 1/5 the same thing as log base 10 5 to the negative 1?
Yeah.
Okay. This is an exponent. It's an exponent inside a logarithm. I may whoosh it so it becomes negative log base 10 of 5. Alright?
Huh.
They gave you log base 10 of 5, so this must be negative 0.699. So what you have to do is manipulate the logarithm they give you until you can use the information they also give you. Sometimes that will not be obvious. Like this? Which one? Yes, that's excellent. That's excellent. Or, sorry, I didn't write on your hand there. Artur did this another way I'd like to show you. Okay? Artur said that the log base 10 of 1/5 is the log base 10 of 1 minus the log base 10 of 5. He expanded the logarithm instead. What is the log base anything of 1?
0.
0, very good. So this equals 0 minus the log base 10 of 5, which is 0 minus 0.699. There's almost always 2 or 3 ways to solve a logarithm problem. And I realize that isn't necessarily helpful. Jordan in particular hates having multiple options. She wants to be told what one way will always work. With logarithms, that's tricky. You got at least 3 or 4 ways to do each one, and you got to use your judgment as to which one's best. Sometimes which one's best for you. Either one of these are fine. I like this one because it's good practice for expanding logarithms. All right? Any quick questions on this? Going once, going twice. And now we're going on to...
Oh, wait, yeah, I had a question. Sorry.
Okay, what is it, Amanda?
46.
46. Okay, can you follow me over here, Becca, so that I don't have to erase that just in case it's relevant again?
It's log base 5 of 8.
Log base 5 of 8, okay.
Minus log base 5 of 12.
Minus log base 5 of 12. The directions on this one, I believe, were to
I
condense.
have no idea.
Thank you for
I don't
showing
like
that.
the direction.
Okay, you should work on that. Log base 5 of 8 minus log base 5 of 12. There is subtraction between logarithms.
Does he divide or add or something?
Right on the first guess. Okay, subtraction between logarithms.
Oh, I did that.
Good, becomes division in between logarithms. Yep,
Like 2, 3 or something.
it is indeed 2/3. Now this is the point where you should ask yourself, do I know what exponent I could raise 5 to get 2 or 3? And the answer in this case should be no. Okay, these are both, that's just, you're done. I have no idea what power you raise 5 to. 5 to the what equals 2/3? I don't know, give me a calculator.
No, that's
I know it's less than 1. Because I know 5 to the first is 5. So I know this is definitely not going to be, this is definitely going to be less than 1. Right, Laura?
Yep.
Good. All right. Okay, back over here, I'm going to start the new thing. Relatively new. Is this new? I don't know. Depends on how comfortable you are with these.
It's today the 29th.
Today is the 29th. I will write that on the board, and you know what? I'm going to get a better marker. This one's dying. Okay, today is April 29th, 2010. And we are doing exponential and logarithmic equations. You can actually start using this to solve things. You notice a lot of the problems we've done haven't had solutions. It's just said expand or condense. Okay? Wrong textbook, Laura. Last hint I'm giving before I throw it out a closed window. Okay. Yes, Yasmin.
I have a question. Did you reduce 8 to 2?
I did. That's all I did over there. Yes, Jordan. I can try. No, I actually can't. I've got the heat all the way up, and it just means the air conditioning should be running a little bit less.
Can I get some water?
Very quickly, please. Okay. Exponential and logarithmic equations. What's the answer? What does x equal?
5.
Dear God, people, please.
No,
Thank
two.
you.
Oh,
2.
two.
Thank you. Think about it a minute. Exponents are not exactly multiplication. They're repeated multiplication. Okay? So you know x equals 2. How did you solve that one?
You
Mine.
said this
Common sense, says Rodney. What'd you say, Sarah?
Mind power.
Mind power. The fact that you've known for years that 5 squared is 25. Okay. This one you should be able to solve pretty much by observation. New example. 5 to the x equals 26. I can tell you it's going to be something pretty close to 2.
Give me 2 point something.
Maybe 2 point something. Probably not. Maybe not even 2.1. Probably even smaller than that.
2
But-
point, oh,
What you don't have is an exact method for solving that. For that matter, you don't have an exact method for solving this. This is just a common piece. I think Rod